All right. Hello, everybody. So I'm Dennis. I work as a machine learning lead at Voicelow, which is a conversational AI company. So what I'll be talking about today is a little bit about this use case of sort of talking with your own data or answering questions. I'll walk you through a little bit of the journey that we went through with some demos at Voicelow when we were building a similar platform. I think it's a little bit interesting because we'll cover a little bit more of the UX questions as well. Like, you're not just writing code, you're trying to figure out how people will use your platform. So, number of things on the agenda. There'll be some technical aspects, some UX aspects. We'll talk about some of the smaller items as well, like token management and other things that typically you don't think about when you're writing code or building a cool demo, but it's important when you're going into sort of a production use case. So when ChatGPT came out, a bunch of these websites or hobbyist projects popped up. Chat with PDF. They made their way into ChatGPT plugins. They were sort of all the rage for a little while on Twitter and LinkedIn. Learn how you can talk with your PDF or your website or something similar. So we saw a lot of these things that popped up, but what's interesting is that people typically didn't know about these type of tasks, these information retrieval tasks. So it seemed that they came out of nowhere in 2023. It's like, why couldn't we do this in 2022 or 2021 or 2020? And the answer is that we could. There have been a bunch of models published on this task, typically called ODQA, or Open Domain Question Answering. This is from a summary paper at the end of 2022, and you can see here there's a bunch of different models here with benchmarks, throughputs, and everything else. But this was typically reserved for an academic space. People weren't working too much on it. There weren't as many demos, at least, on the social media platforms. So what's interesting is that to actually measure how good a retrieval system is, you need some kind of benchmark. And to my earlier joke of having a drink, there's this benchmark called beer. So beer takes in a bunch of different data sets across, I don't remember how many there are, from different years and different domains. So we have MS Marco, which is a search data set, which was quite amazing for fine-tuning language models to do information retrieval. We have some other ones for financial data, for COVID questions, etc. So this benchmark is great for actually measuring how good is your ability to retrieve questions and answers from a system. And you can see here, the data sort of goes back to before 2023. So this wasn't a problem that we were just thinking about now. What's also interesting here is that typically you fine-tune your model based on your data set. So when you talk about this question of chat with any PDF, chat with any website, you start using typically an unsupervised approach, unless you can fine-tune a model very, very quickly on your user's data. So this is pretty interesting. One thing that you can think about as well is, what if you combine this idea of chatting with a document with a persona as well? So this is a little project I built in 2 minutes, basically chatting with Darth Vader about Git. I call it GetDarth. So basically, I uploaded a document about Git, and I can ask it different questions. So here I can talk about the rebase, ask what is a Git add. And I basically asked the summarization step here to assume the persona of Darth Vader. So you can see here, it inserts things like the Force, the Rebellion, etc. So now we have this concept of we're doing information retrieval. We're talking to your data, so to say, but we're also using this concept of a persona. And it's actually very easy to do with large language models, which I'll get into in a little bit. So there's a lot of cool stuff that you can do here. And when ChatGPT initially came out, Voicelow as a company was thinking about, okay, this is getting quite popular, this ability to build instant assistance or talk with data. So we built a quick proof of concept on this without using sort of fancy front end or anything crazy, something that we did in January and February. So this is what I wanted to show here. Yeah. So we built this project. You can see here it still has a generic name like Q&A test. And this is something that we use to actually train on our own data. So on our own blog and our own Zendesk tickets. And you could basically ask it questions like, what is AI Assist, which is one of our features that we have? Or we can ask something else like, what is intent? So this is something we built in January 2023 because we want to validate if is this useful, how hard is it to do, how do we actually jump into this information retrieval aspect, and how do we deal with some of the issues that LLMs face, like hallucinations, document reference, all that fun stuff, right? So we built this proof of concept just to validate that it works, and from there forward, we sort of shared it with some of our customers and internally to see if it's well used. So this is kind of what the architecture looked like. It's nothing out of the ordinary, but basically we connected our sort of front end to this API that we deployed on Google Cloud Run. So this is different than our typical API deployment steps. We go through a whole CI/CD process on Kubernetes, but because it was a proof of concept, we wanted to hack it together. We had authentication on it just to make sure it's fairly secure. So we used a proxy service for that on GCP. And then we used OpenAI for both the embeddings and the LLM retrieval steps. And we built a pre-processing step which would ingest all this different data from our blog and our Zendesk into the vector database. So I won't go into too many details about each of these different components, but we basically drew this out, built the proof of concept in sort of a week and a half, just to validate how it would work, because it was based on something that the space we worked in. Now, two concepts I wanted to touch on too, and are the actual retrieval system and embedding. So everybody's probably coming from a slightly different background on these topics, but starting off with the retrieval system, the core idea is that you have some kind of information that you put into, that you have in a database, or in this case, they call it an archive. This is from the Cohere's semantic search docs. It can be in a vector database, it can be in a regular database, doesn't matter. Then you do some kind of search. Typically, we have heard of the term semantic search. So you compare the similarity of a question and the answer, and then you serve the search results. And the search is based on the semantic similarity, which is based on embeddings, right? So converting text into some kind of vector that you can compare. Now, search results just from documents might be not very useful, right? If I give you a doc on Git and it's a 100-page PDF, I don't want you just to give me the whole PDF back. I want you to give me something useful in a potentially conversational fashion, and potentially answering as Darth Vader. Now, choosing which embedding model to use is also a pretty interesting task. On Hugging Face, they have this MTEB dashboard, which basically has a collection of different tasks for retrieval. So classification, clustering, it's basically a whole bunch of unsupervised approaches. And you can click on all the models and see how they do, right? So this is something very, very useful, actually, and something that I wasn't aware of until a couple of months ago, even though I work in the space, so I should have probably kept better track. But you can basically see all these different models, click on them, and there's obviously trade-offs between accuracy, speed, and other things. And they do well on different tasks, or the different models do rather, so you can figure out which task you're working on. Are you doing it on a retrieval task? Is it summarization, re-ranking? Because all of these can be part of a fairly complicated pipeline. Or maybe sequence length is the most important thing to you because you're doing it on big documents, so you want a model for that. So pretty interesting data set or benchmark to look through, highly recommend it. It also will help you determine which kind of embedding model that you can use. So in June of this year, A16Z, I can never pronounce their proper VC name, Andreessen Horowitz, I think. But they released sort of this architecture in June talking about this LLM App Stack. So There's a number of different components here, but to get started, you don't need to incorporate all of it. Some of these things I'm not sure are actually needed or should be done. Like I wouldn't host a production application on Streamlit, for example, for if you're running a big application. But regardless, there's more and more work being done in the space about diagram or about design, about LLM systems. So definitely something to keep in mind and sort of look through. Depending what kind of background you're coming from, these diagrams might resonate differently, so they're quite helpful to actually learn the space. So after doing that proof of concept, we actually ended up building this feature called the Voicelow knowledge base. So you can upload some data, whether it's from a PDF, a URL, or other sources, and you can basically get an answer from it. So it took a little while between that proof of concept in January sort of to the May timeframe that we released it, both on a technical level, but also on a product decision level, right? So as a company, we focus on conversational AI, both sort of for design and hosting options. But we didn't see sort of, would our main customers, which are enterprises, would they find this useful, right? Because as an enterprise, typically I'm not just going to upload my data somewhere and then just have an LLM respond on it. Typically there's stricter security controls, compliance controls, all these different things. So we weren't actually sure if this was a valid thing to do given our enterprise customer base. So this is something interesting also to consider, is that when you're building this kind of product, it's not just what's the coolest tech. You actually need to figure out what your customers want. And we actually went back and forth and decided that this is a worthwhile experiment to build. And even if it doesn't work on the enterprise customer side, it might work with new sort of developments, right? So very interesting space from like a business perspective. There's all these different apps out there for personal use, commercial use. So interesting to see how people have productized and monetized it. So when we first built the knowledge base, we actually built it as a fallback option. Basically, if you designed a chatbot and somebody said something that the chatbot didn't know, you would go ahead and retrieve from the knowledge base. We didn't actually know how people would use the product, so we started off with that as it was the simplest option. But we quickly found that wasn't the main use case that people were working on. So it kind of looked like this. You'd have a chatbot going, and then when somebody says something that you don't know how to answer, you hit something called the none intent, so it didn't match what the user said, and you go ahead and hit that knowledge base fallback. So that was the initial design, but people wanted something else. People wanted more, which is a good problem to have. And one of the things that people thought that they could use, we have these different AI steps within Voicelow. So they thought that they could actually put in a prompt that gave instructions to search the knowledge base. So we saw that this was a recurring UX pattern. People are like, yeah, I don't just want to talk with my document. I want to talk with the system that configures my document, which is actually very interesting, right? Because now you're not just working on doing retrieval, you're actually handling sort of processing a user's question into a set of commands for the knowledge base to retrieve. So what we ended up doing is we ended up adding a knowledge base step or incorporating it into our AI steps, because that's what people wanted to do, right? And from a technical perspective, we didn't make it too complicated to add because we were thinking about this in the long term, but in the short term, not something that we thought we wanted to build. So if we go onto the canvas here, right, this is what it looks like. This is the whole Darth Vader AI assistant. And we wanted to validate the ideas that if you made this super easy to build, people would actually use it versus building a complete sort of chatbot. So you can see here, I have this response step, and there's different data sources. We added this toggle for this knowledge base, right? So rather than having a model just respond based on the prompt, you actually have it respond based on the knowledge base. And that information is stored here within the knowledge base itself, right? Here's my little Git tutorial from Atlassian that I uploaded an hour ago. So these are kind of the things that we were thinking about, and we were monitoring usage to see how do people actually use the system, right? Because we saw demos of it, but demos and how people actually use stuff is very different. So the other thing is that people started wanting to have more power over prompts. So originally what we had is in the knowledge base, it was just a very simple prompt. We didn't let users configure it. But if I go back here, actually, you can see that I'm using a custom prompt, right? So I'm saying speak like Darth Vader, and then I provide the question that the user asks. And that worked fine, but people then wanted to be more and more creative with their prompts. They wanted to have more control on how to use the knowledge base. So we started seeing things like this. Somebody wanted to have a multi-tenanted use case, meaning that they might upload PDFs or URLs based on different customers. For example, they might be like a retailer, right? And they might have one vendor which sells one type of toy and another vendor that sells another one. And the customer might want to search based on each vendor. So now that gets pretty interesting because now you have to be able to tag and differentiate and identify these properties that somebody wants to use. So this becomes this task of figuring out what is this entity or what is this tag. And it's interesting because is this something that the user should configure ahead of time, or should you expose your large language model or retrieval system to dynamic sort of questions and tagging, something that we've been thinking about. And you might have multiple tags or questions or settings. For example, here, you might have tagged your data in some system as unread. So you can think about it as some kind of knowledge base or database with different properties, and you're now using natural language to query it in this way. So it gets very complicated very quickly, where you've gone from an information store, ask a question, get an answer, to now you have to process user questions to try to figure out how you can extract exactly what the user wants to do. So now it turns into this task of entity recognition, right? So how do you find entities or things that users might want to look for? Because we know that when we work with large language models, that we either have to fine tune them or we have to do multi-shot learning, few-shot learning. So you somehow need to know which things for which customer or for which end user are actually going to be relevant tags. So for example, I might have this kind of question that I might ask, but Amir might have completely different tags or things he wants to work on. So you have to generalize it somehow. And what you end up having to do is do this at your DB level. So you might want to have tags at your DB that the user can configure. You might have to have these and or clauses that you convert from your prompt. It gets very tricky very quickly. So we have not actually implemented this for now because it adds so much complexity to the system. So even though it is a user request, people wanted, we've put our foot down and said, this doesn't actually make sense for this task, for the amount of challenge that it's gonna bring us. So building this kind of system, you sort of get into some interesting details, right? After you've built the initial chat with your PDF or chat with your website kind of thing. And adding more and more features, you have to be very careful because A, you add complexity, but B, you add potentially security vulnerabilities, right? So if somebody does a prompt injection, and this, for example, is a variable, like I am, for example, customer A, and I'm looking for my own documentation. What if I say search customer B's? Like, let's say I work at a rival platform is using this chatbot, and somehow the data isn't isolated, right? So you have to be very careful for all these different prompt injections on all these different things, because if you don't design the system properly and you built it quickly, suddenly somebody might be pulling all the data or querying your database in a weird way. So always have to be careful with these things. So that's why you have to try to make sure that things are simple and you test it out properly. So talking a little bit about the UX, the design of the system, we also made some choices on the LLM side of things, both on the embedding and the summarization layer. So on the summarization layer, we we summarized here, I guess, the cost of retrieval tasks and a few shot learning, right? So I think this is something really important to think about, is that GPT-4 is a very powerful model, but it's expensive, right? If you're asking the knowledge base and you end up having sort of 2K tokens in your context, suddenly you just paid 12 cents, right? If you're using the long context, or 6 cents for the shorter context one, as compared to something like ChatGPT, Claude, or Bison. So very important thing to consider. Something that we're trying to figure out as a platform is which of these models is optimal. And we ended up going with Claude as the model that we chose. There's also this question of latency, right? So if you're asking a knowledge base or any chatbot for something and it takes too long, you're just going to walk away, right? It's just annoying. You see that little bubble that's animated in, right? So we have to make sure that the latency matches. And this is a quick diagram from Helicone tracking ChatGPT's latency. So you can see it has quite a bit of fluctuation, which is fairly challenging when you're trying to use that LLM for your use case. So what we ended up doing after initial proof of concepts, we switched over to Azure ChatGPT to reduce that latency and also reduce that standard deviation, because we found that there was quite a bit of jitter or the P99s and P95s requests were very, very high. So for both sort of security and compliance reasons for some of our customers, but also for the benefit of the platform, we ended up going with Azure, and we wanted to measure what that looked like. And we did so for a number of different models, ChatGPT, Claude, Claude Instant, just because we wanted to make sure the default that we provided for our knowledge base was reasonable. It had good accuracy for responses, but also was quite fast. And we ended up going with Claude as the default. So what that looks like is if you open up the project, there we go here, go to settings. You can see here that we're using Claude V1, but you can select other models. And as a platform, we want to allow people to select other models. So this is something we actually have to maintain on our own end, is that you're not just experimenting for your own use case, you actually have to support it for a number of different use cases. So we ended up saying, these are the models we have so far. We try to provide some information for customers as well on how to use them and what the pricing impact is. So the next thing is that how do you actually price a system like this, especially when you have different tokens or different models? So when we were doing an investigation sort of throughout the past year, adding different models as they came out, we were tracking sort of these different parameters, right? Cost, performance, speed, span or context length, and the languages that we had. And it was pretty interesting just to go through this whole exercise, right, to figure out what it costs. And we ended up going with Claude for our knowledge base, but for other systems, we use ChatGPT as the default. And we wanted to figure out what's the pricing look like when we don't want to eat all the costs for the tokens, because they can be quite expensive, but we want to make sure that people can actually build reasonable assistants and actually chat with your documents, right? Imagine if you could only ask one question, you uploaded a document, and then that's all. So we ended up using this token system based on OpenAI's ChatGPT one, and we added a conversion for GPT-4. We roughly 10x the cost, even though it's closer to 20 to 30, just for simplicity's sakes when a user is using that. So it becomes a little bit interesting for tracking when you have multiple models, multiple use cases across these different things. So it's still something that we're figuring out, because you have also different users in mind. Some users are power users, they're sort of burning through the tokens. Others are using other parts of the platform. Now, the final thing I wanted to talk about is that to test our knowledge base out, in general, our LLM stuff, building out this testing framework where you can basically pass in transcripts, various parameters, models, prompts, and go through and validate how things work. And the reason that we need to do this is because when we were trying to make these product decisions of, okay, should we use Claude, should we use ChatGPT, what kind of prompt should we put? We're running into this edge case. Is it a model limitation? Is it a chunking limitation? What's the actual issue? And that's very hard to say, right? You kind of run something on your own computer or wherever to do some quick tests, but that's not systematic at all. So we're building out this testing framework, something that we're adding in for the knowledge-based product specifically because it has raised these questions. How do you pick a good prompt? How many examples do you need for few-shot learning? Do you need them? Is your chunking strategy working? All these different things for this information sort of retrieval kind of task. So we're doing internal testing for that, and hopefully at some point we'll be able to share a little bit more about the details on how it works. But that's it for me. It's a little bit of our journey about building this kind of system. Hopefully it was interesting to see it from sort of a platform side, not just a consumption side, and happy to answer any questions about the process itself.